Greetings. Today we're going to learn on how to balance chemical equations. Okay, so this concept is examined in grade 10, 11, and 12, but it's taught in grade 10, I think. So now I'll quickly give myself an equation at random so that we solve, and I try to show you the procedures. So let's assume that the hydrogen gas, which is a diatomic molecule, reacts with oxygen, which is a gas and a diatomic molecule also, to form the water molecule, which is going to be in a form of liquid. So now, is the equation balanced? There is only the only one way to find out. So you will quickly write the left hand side here together with the right hand side. Remember, this is the side of the reactants, and then this is the side of the products. So now you quickly check what's reacting on the left hand side. That you have hydrogen and oxygen. If they are reacting this side, it means that they will form a product that side. You simply rewrite them here. How many hydrogens do you have on the left hand side? You have 2. And then how many oxygens? 2 also. Then you go to the right hand side. How many hydrogens do you have? You're going to have 2. And then how many oxygens? You only have 1. So now, is the equation balanced? No. Picture a situation where you poured 3 spoons of sugar in your tea, but when you will be drinking, you find that the taste is for 1. Is it possible? So now let's try to make oxygens 2 also on the side of the products. How can you do that? You multiply, you see this 2 here, you take it, you multiply by it here, and you put it here as the coefficient. So now how many oxygens do you have this side? You have 2. And how many this side? You have 2. Oxygens are balanced. Then we move to hydrogens. How many hydrogens do you have this side? It's 2 times 2, which is 4. We have 4 hydrogens. How many do we have this side? We only have 2. What is it that you can do to make them 4 also? You take this 2 here, you multiply by it this side, then you will have 4. That you put this 2 here as the coefficient. So now the equation is balanced. So now let's do the second problem. Okay, the synthesis of ammonia. Okay, ammonia is given by NH3. When you say something is a synthesis reaction, we simply mean that 2 or more molecules will combine to form new products. That's nitrogen, which is a diatomic molecule, as a gas. It will react with hydrogen gas to form this NH3. So now, is the equation balanced? You follow the very same procedure. Left hand side, then right hand side. What's reacting on the left hand side? It's nitrogen together with hydrogen, which simply means that on the side of the product you must find nitrogen and hydrogen. Nothing else from somewhere where we don't know. Picture a situation where you'll be making yourself a cup of tea. You pour sugar, but when you'll be drinking, you find salt. Where does the salt come from? So it's like that. So now nitrogen. How many nitrogens do you have on the left hand side? We have 2. And then how many hydrogens? We have 2 also. On the right hand side, how many nitrogens? 1. How many hydrogens? 3. Is the equation balanced? The equation is not balanced. Everyone can see. So now let's follow the very same procedure and try to balance this one. How can we balance this equation? You take this 2, you multiply by it here, which means that you put this, you're going to introduce this 2 here as the coefficient. How many hydrogens are you going to have this side now? You're going to have 6. And then what is it that you can do to make them 6 also this side? You multiply by this 3 here. Take this 3, put it here, which means that you're going to take this 3 and introduce it here as the coefficient. If you multiply by this 3 here, you have to put it here also as a coefficient. That's 3 times 2 is going to be 6. So which means that you have 6 hydrogens on the left hand side and 6 hydrogens on the right hand side, which means that hydrogens are balanced now. So we move straight to check the hydrogens. How many hydrogens do we have on the left hand side? We have 2 multiplied by 1, which is invisible here. Then we will have how many? 2 nitrogens. How many nitrogens do we have on the left hand side? We have 2. Therefore the equation is balanced. So now, in attempting to balance the equation, I have generated the rule which says products first and reactants after. You start by manipulating the products and then you finish or end with the reactants. You should have noticed that here I've started by manipulating this product here. We introduced this coefficient first and then the reactant was the last. And also here we manipulated this reactant here, this product, and then the reactants were the last also. So can we try to balance this one? I'm just gonna give the equation at random. Please pause and try to balance it, and then we'll then do it together after. Sodium and water. Sodium reacting with water, H2O, which is a liquid. They will form sodium hydroxide, which is an aqueous solution, plus hydrogen, which is a gas. So now pause and try to balance this one. Okay, good. Let's continue. Let's try to solve this one together. You follow the very same procedure, left-hand side, then the right-hand side. What's reacting on the left-hand side? You have sodium, you have hydrogen, and then you have oxygen. Then you simply rewrite these reactants. This is sugar, coffee, and then milk. Okay, lol. So now, how many sodiums do you have on the left-hand side? You have 1. How many hydrogens? 2. And then 1 oxygen. You go to the right hand side, you collect your data. Sodiums you have 1, and then hydrogens you have 1 plus these 2 here. Then you will have 3, and then for oxygens you will have 1. Now if you check, oxygen is balanced, hydrogen is not balanced, and sodium is balanced. What is it that you can do to make sure that your hydrogens are balanced? What is it that you can do? So now we will quickly add, let's go for the simplest way. We'll quickly take these 2 here. You see these 2 here for the hydrogen. You take it, you put it here. Again, just take it, you put it here. And then how many hydrogens are we going to have now? You're going to have 2 plus 4. Then which means that you're going to have plus 1 here. You're going to have 4 hydrogens on the left-hand side. You just have to be manipulative. Now we're moving away from the multiplying thing, but still we start by manipulating the products. Products first, then reactants after. So now, what is it that you can do to make the hydrogens 4 also this side? You multiply by 2, the common factor. You multiply by 2. Then which means that this 2 you put or introduce it here as a coefficient. So now you'll have 4 hydrogens. So hydrogens are balanced. Now we move to oxygens. Are the oxygens balanced? You check the right hand side. You have how many oxygens? We have 2 now. 2 oxygens. You go to the left hand side. How many oxygens? We have 2 also this side. Going to have 2 also this side. Therefore, oxygens are also balanced. Now we check the sodiums. How many sodiums do you have on the right hand side? We have 2. And then you check the left hand side also. How many do you have? We have 1. Then you multiply by 2 and introduce this 2 as a coefficient here. Then you will have 2. Therefore, the equation is balanced. So now, can you go and do the synthesis of calcium carbonate? You are more than welcome to text me on WhatsApp. It's 0765924017. Share your answers for this one, the synthesis of calcium carbonate, and seek for more clarity. Everything is for free. You're not going to pay anything at all. And remember to subscribe on YouTube. It's Kidiot.SA, written like this, Kidiot_SA. So you are more than welcome to text me, to leave comments on how I can improve this educational content so that it benefits South Africans and also the students at large. Thank you very much, and shout out to you. Don't forget to subscribe to my YouTube channel and turn on the notification buttons, as I'll be sharing content each and every day. Thank you. Bye. Good night.